water pollution, and we're going to go through this fairly quickly because some of it is stuff that you've really learned before, and then some of it is stuff that I'm going to go in detail for you. So as we go through, you're going to want to fill in the blanks on your note sheet. Some areas you won't fill in the blank, you'll just kind of listen. And then, of course, there's spaces on the side if you want to jot down any extra helpful information or stuff that is fascinating to you. So there are two kinds of water pollution. One kind, if we look over here, says point source. And the way that you can remember that point source is because you can point to the source. You can identify the source. This is direct discharge into the water. Things like sewer treatment plants. Things like dumping toxics from industrial facilities. You can follow the dump back to where it is coming from, so you can point to it. These are going to be examples like wastewater from factories, and it can be controlled. Why do we say it can be controlled? Because you know where it's coming from. If you know the source of the problem, then you can fix the problem. So you can go to those sewage treatment plants, or you can go to that factory and say, hey, you have to stop dumping in this water. You can follow the trail. You can point to it. The other type of water pollution is non-point source. This is indirect discharge into the water, things like urban runoff and agricultural runoff. You cannot see exactly who put that pollution there. You just see the accumulation of the pollution that is there in the water. So things like trash on the side of the road, that is non-point source. You may see someone throw a cup out their window, but all of that trash there, you can't pick up a piece of trash and say, okay, now I have to be Inspector Gadget, and I can trace this right back to so-and-so's home. They did this, and I need them to stop because then that will eliminate all of this pollution. No. And it's difficult to control. Why? Because you don't know where it's coming from. Any questions? Although you have words up here to help you with your notes, should you be writing them word for word? No, you should probably be putting them in your own words and kind of shorthanding because I am moving. Here's an example here with the black arrow. This would be considered point source. Why do I call that point source? Because we can follow that barrel or that tube there back to where that pollution is coming from. Over here with the blue arrow, this will be considered non-point source because all this trash in the water, you cannot identify exactly where each individual piece of trash came from, so you can have it stopped. Any questions? Okay. In addition to point source and non-point source pollution, there's also something called thermal pollution. Thermal obviously comes from the word therame, the Latin word therame, which means heat. So this obviously is pollution of heat. This is where the temperature change caused by human influence, meaning that we did something to increase the temperature of the water. And the water that we're talking about are natural bodies of water. And if we increase the temperature of the water, we're going to decrease the oxygen, which also kills off animals, aquatic life. And it could affect land life, like birds, the birds that rely on the fish for food. So it puts our food web and food chain in an unbalanced state. Any questions? Got it? Okay, so from pollution, we get some things called contamination plumes. And these are formed when contaminated underground spreads by groundwater. So for instance, in this area up here, at the very top is where we would have some pollution. This is our recharge zone. This means that what happens in the recharge zone? The water does what? It breaks what? It breaks into land called? Nope, infiltration. And even when the water is breaking through the land, what else is breaking through the land? Any of the pollutants that are there. That water then moves through the land, which is called? The movement of water is called? You better get your notes out. Percolation. So that waste is percolating through the land as well. And that's going to move down through our zone of aeration, past our water table, through our zone of saturation, and the water's being carried there, but what else is being carried? The pollution's being carried there. And if we notice here, actually, they've already noted out our contamination source, which infiltrates, then percolates, and it gets down in this area that you see red here. You have your water flowing, and it's going to pull that pollution, which then becomes a contamination plume underground. Now, we dig wells, so this well is at risk because it's tapping into this water, and eventually this pollution is going to move their well, and that is going to contaminate that well. Now, that may just be a well for one person's home, or it may be a well for a community of homes like here where we live at. Do you see how this is a problem? Okay, any questions? All right, very good. We're going to talk about what pollutants can do. We're going to lay down the 5 things that it can do, and then we're going to break down those 5 things. And this is in no particular order. But pollutants can actually change the temperature. So if we add things to the water that do not belong there, the temperature could change. It could increase the temperature or decrease the temperature. In addition to changing the temperature, pollutants can also change the pH, which is the power of hydrogen. And we'll talk about these as we go along, so I'm not going to elaborate much as I'm pointing each of them out. Pollutants can also decrease DO levels, and in a moment you will find out what DO means. Pollutants can also increase nitrate levels. What element do you think we're talking about? Nitrogen. And pollution can increase turbidity in water. Overall, pollution will harm plants, animals, and humans. Because we all rely on what? Water. It's the essential element. It's the essential liquid for life. Any questions? Essential means it's very necessary. We need it to survive. Can I move? Okay, so we're going to go through each of these and discuss how pollutants affect each area and information about that area. So, starting with temperature. The healthy temperature of a body of water is about 25 degrees Celsius to 45 degrees Celsius. This is healthy. Now, individuals working for different plants for water work to make sure that the water that we use on a daily basis is healthy for us. So when we talked the other day about water usage, and we talked about how government regulates water usage, then they are going to be looking at these areas, the turbidity, the temperature, the oxygen levels, the nitrate levels. They're going to be looking at all of these areas. So when they do, and they check the water, they see if it's falling between this range. If it falls below or above this, then there are some issues that need to be looked at. So this is the healthy temperature. Any questions? Okay. The power of hydrogen is another factor of pollution, another factor that can be affected by pollution. The pH is going to identify the acidicness or the basicness of water. Everything has a pH. We can even say that our social life has a pH. We want it to be really neutral. We want to have friends. We know we can't get along with everyone, but we want to make sure that we have a very neutral life where our days go smoothly. But at any given moment, something could happen which would throw us off our mood, whether we're overly excited or whether we're down in the dumps. And when those things happen, then we're off balance. We're not balanced and we're not neutral, correct? And the same thing happens with the environment of our water along with the environment of other things. Our body also has a pH level in different parts of our body that has to be regulated based on the things we talked about in biology. pH is going to range from the number 0 to 14. And there are pH scales, and we use that scale to see where the pH falls, and we determine the acidness or the basicness, the acidicness or the basicness of a substance. If a substance falls between 8 and 14, there's an increase in alkalinity, which means it's high in base. It has a presence of base. When I say high, I mean if it's at 14, but if it's between 8 and 14, there is a presence of a base there. If it's right in the middle at 7, the substance is neutral, meaning there's no acid and there's no base. What do we want to be neutral? Your what? What are we talking about? Water. We don't want acids or bases to be in our water, do we? We don't want anything to be in our water. Our water should be very neutral. We just want it to be just water. If it falls between 6 to 0 or 0 to 6, then it's acidic, meaning there is a presence of an acid there. And we're going to talk about some things that are bases and some things that are acid in a moment. Okay? Your normal pH for your water, although we want it to be at 7, meaning that nothing's there, the normal pH that the government has said is okay in our area is between 6.5 and 8.5. So at any given moment, our water can be a little bit acidic or a little bit basic. But those levels are pretty normal because that's as close to 7 as we can get. By nature, water is not pure because it comes from underground, and we have other things in our environment that change the pH levels. Pure water, obviously, we said is 7, and that is very healthy. And this is what the bottled water tries to achieve for you, giving you pure water. The water that comes out of our faucet falls between the 6.5 and the 8.5. Now, if you check your water and it comes out to be 9, 10, 11, or 5, 4, 3, then we got a problem. Okay? pH is important for living things. We're going to talk about the importance of the pH for living things, but first, just showing you this. These are these little things here. Those are called litmus paper. And litmus paper is what's used to check the acidicness or the basicness of a substance, any substance. But for what we're talking about here, for water, what will happen, we'll take that little piece of litmus paper and we dip it in the water. The litmus paper has a chemical on it which checks for the acidicness or the basicness. So that chemical, if there is a chemical in the water, is going to react with the chemical on the litmus paper. It will change a certain color, which we see here on this chart. Whatever color it changes, we hold it up to the chart and see what color matches. If it matches, let's say, this one here, then we would consider it a 4, has a pH of 4, which tells us what about that water? It's acidic. If it matches here, which is a 13, it will tell us what about the water? There is a presence of a base. It's basic. And that's how we check the pH. And that's what organizations do when they're checking the pH of water. Now, why is the pH of water important for living things? What did we just say about water? Water being what? It's the main source what? Of life, meaning that what? We all need it. It's essential for living things. And if the pH is thrown off, then it can harm us. Very good. Do not write that word for word. Like you already told me, that your living things and every organism survives in a specific pH. And when the pH is unbalanced, so is the organism. And their survival is threatened. So basically, living organisms depend on what? Depend on, what are we talking about? A specific pH. And when that is what? Unbalanced, then it what? It harms us or it threatens us. It is a threat to us. Any questions? Can I move? Okay. Then the next thing we're going to talk about in a moment, I just want to show you this here. On your paper, you have a chart that looks like this. This is like a chart that was on the previous page. Now, every chart can be different depending on the litmus paper that you have. All litmus paper will test the pH, but the colors will be different. And you'll have a chart for everything. That's an indicator to show you. It's a comparison indicator where you can see if it's acidic or basic. So I don't want you to always think that if it's red, then it's, or purplish red, then it's always a number 14, because as you can see from the previous one, there were more oranges and greens on that one. So you'll use a chart, something like this, to hold your litmus paper up to, depending on whatever chart is provided for you. Now, for this particular chart here, and any chart, it still has the same level, 0 through 14. And battery acid would still be at a level 0, no matter the color of the chart. So if you look at your chart, it kind of tells you what some things that are acidic and some things are basic, to give you an idea of what we mean by bases and acids. So battery acid obviously is the most acidic from what we're talking about here. If you look at the acid in your stomach, that's pretty acidic as well. If we move on further to the chart near the 14, things like drain cleaner, that's the stuff you pour down your toilet or your sink if it's clogged. That's very basic. Things like baking soda is it's closer to neutral, but it still has a presence of base. Those are basic. Baking soda is what's used to neutralize your fridge if it has smells. It's also used, some people use it to brush their teeth. They also put it in toothpaste to help whiten your teeth. But if we look in the common range for natural waters, what else falls in that range? Urine falls in that range. Look at where urine is. It's a number 6. It's not that far off from 7. It has some presence of acid, but it's close to being pretty neutral, providing the fact that you're healthy. Now, you could do other things with your system, things that you eat and drink, where your urine could be a little bit acidic or a little bit basic. But healthy urine is right close to being neutral. So is your saliva. All right, any questions about that? And we notice that pure water is at 7. All right, the next thing discussed is DO levels. Remember, pollution can change the DO levels. DO is dissolved oxygen, so it's basically the oxygen levels. So what they do, they check the amount of dissolved oxygen in a healthy stream. And we measured in something called ppms, which is parts per million, and we'll talk about that a little bit later. Obviously, the oxygen in the water comes from the process called, how does oxygen get back into our environment? You're kidding me, right? Yeah, and what is that process called? We don't breathe oxygen into the environment. Where do we get our oxygen from? Plants. And what is that process where plants make oxygen? Why is it like I have to pull your teeth out of your mouth for you to think? Come on, people, get it together. And we know that plants are in our water, and those plants need what to make oxygen? What do plants need to make oxygen? Sun. And if there's pollutants in the water, what is it going to block? The sun. Therefore, the oxygen levels are going to be low. Very good. And our organisms in the water, along with the organisms outside the water, rely on that. But if it's polluted, that's going to affect the DO levels. Nitrate levels. Nitrate comes from what element? Nitrogen. And we talked about the nitrogen cycle and how those elements get through our environment. Nitrogen is needed by living plants, animals, and it helps to build protein. We need nitrogen. But we also talked about the badness of nitrogen, the harmfulness of nitrogen. If there's too much nitrogen, what could happen to our water? It could produce acid rain. Nitrogen, or nitrates, come from fertilizers, natural and synthetic fertilizers. Synthetic meaning the ones that you buy from Home Depot and Lowe's. Natural means what? Cow manure, any type of animal manure, actually. And we are animals, even our manure. It also comes from industrial waste, that's farmland as well. And your sewage, that's human waste. So sources of nitrates that get into our groundwater would be things like fertilizers, manure, wastewater, septic tanks, that's where our poop goes. And dead organisms that die. Remember, they release nitrogen back into the earth. Question. There is something called eutrophication. Eutrophication is a Greek word for development. And eutrophication happens when we overplenish the earth with nutrients or fertilizers. And that happens something like this. It's through sewage and septic tanks and cow manure and everything that fertilizes the ground and gives the ground nitrates. So if we look here, we have a cow doing its business. We have chickens there. We have a farm. You have plants that fertilizers for plants. All of that gets into the ground. And when it gets into the ground, then it flows into the groundwater. Those groundwaters are released back into bodies of water, which then puts the fishies and the other organisms there back at their demise. It's not the poop that gets there, but it's the nitrates, and it's over nitrating underground, which is eutrophication. Next thing is turbidity. Turbidity is the amount of particles in water. Basically, it's how wet the water is. Clear. There's a lot of particles in the water. Is it going to be a high turbidity or a low turbidity? High. There's not a lot of particles in the water. The water is going to look clear. So it'll be a high turbidity or a low turbidity? Low turbidity. Sometimes turbidity is checked in this fashion, where you place the water in front of a dark line and you see if you can see through it. This bottle of water here would obviously have high or low turbidity. Low. This bottle of water here would have a turbidity high or low. High, because why? You cannot see the line there. Sometimes they use something called a Secchi disc. And the Secchi disc has contrast colors, black and white, and they put a string on it. And the string is very, very, very long. And the string has notches. 1, 2, 3, 4, 5, all the way up to whatever number that the string is. And what they do is they lower that into the body of water. And they keep lowering until until when? What do you think? Until they can't see it anymore. And when they can't see it, they stop at that notch and then they count those notches. And that's how they determine how turbid it is. Now, if they can lower it very, very, very far down to the very last notch, and that water is considered to be low turbidity. They can see that Secchi disc. But if they can't lower it, let's say they only can lower it to this notch, then it's high turbidity because they can't see it after one notch, and then we have a problem. Any questions? All right, the next thing we're going to talk about is how to conserve water. And we talked about this when we did our little scenarios. The major way to conserve water is only use what's needed. That's what the gist of everything that you talked about. Don't overuse water. Just use what is needed. And what you do not use, you can do what with it? Save it or recycle it. Recycle or reuse. So I would put recycle or reuse. Recycling meaning we talked about giving it to your plants or giving it to your animals, or reusing it, saving it, putting it in the refrigerator and using it later. Putting it in your wash machine so you don't have to use much more water for that. Now, how do we treat wastewater? Because it's water, we need to treat it because we know that there's waste in it. We use things like sewage treatment plants, and we use things in our homes like septic tanks. And if you flip your papers over to the back, we're going to quickly talk about sewage treatment plants. Any questions? We have 2 papers. All right. Wastewater treatment is made simple. We're going to look at what wastewater is and why we treat wastewater. Much of wastewater, and right now you're not writing up here, just look. It's going to be used by homes, industries, schools, everywhere is going to be using water. But before we can allow people to use it, we have to treat it so that we can get it back into the environment to use. Now, if wastewater treatment is something that you're not familiar with, then wastewater is basically water that has been used. So it's called used water. Wastewater equals used water. Now you're right. Not writing. Just to give you a little gist of it, by nature, your environment or your nature is going to automatically clean itself. It's just going to take care of itself. So when the water's in the air, it's going to automatically try to neutralize everything. However, it has become overwhelmed with environmental usage, human usage, where it can't really fix it all by itself. So this is when we have to come into play and add sewage treatment plants so that we can assist the environment with handling all of the pollution that it is bombarded with, so that we can put it back into the environment so that we all can use it and be okay. Now, how many of you would be satisfied if you turned on your shower? Oh, wait, none of you turned on your shower this morning or last night. Just to see if it worked?
Yeah.
Okay. How many of your parents, because we all know teenagers don't shower, how many of your parents would be happy if they turned on the shower, or let's say this, because you all are garbage disposals, meaning you eat everything that comes into the house. But if you turned on your sink to cook you something, how many of you would be pretty happy if that water came out brown? How many of you would let it continue to flow until it turned clear? And then you would still use it? How many of you would be okay if you turned that water on and it was like a doo-doo green? With stuff floating in it. No. So because of that, we have put into place things like sewage treatment plants to clean that water. Because if we didn't, there would be the possibility that you would turn your water on and things would flow out of it. Bugs and everything. Now, wastewater is used water. And wastewater includes substances such as human waste. So water that has been used includes human waste. Now you are writing. Water that has been used also includes things like food scraps. You don't know it because it goes through a sewage treatment plant, but would you be okay if you turned your faucet on and little apple pieces came out? Wastewater also includes things like oils. It includes other chemicals, just a variety of different other chemicals, too many to list. And it also includes soaps and detergents. Your water was bubbling. You like that? Not because it's soda. Okay. All right. Wastewater, it comes from homes. Now, what parts in your homes can it come from? Your toilet, you can write down a couple examples. You can just put your bathroom, you can put your toilet, whatever examples that you like, but toilet is a good one. What else in your bathroom? Your sink, your shower. Took you a long time to figure that one out. Wonder why. And your bathtubs. So things like your sinks, your bathtub, your shower. What about in your laundry room? Your washing machine, it can come from, wastewater can come from there. What about in your cocina, like the kitchen? Dishwasher, your sink, your refrigerator may filter out some water. Yep, all of those things are good. Even your garbage disposal, because water flows down there and you put stuff through there. Water coming from your oven?
Like it can clean it.
But that doesn't use the water. It burns it out. Yeah, my oven cleans itself, but it burns it out, and then you wipe out all the ashes. What other areas that are not listed on here could wastewater come from your home? Your water tank. Okay, what else? Your water hose or your irrigation system. Your swimming pool. All right. Wastewater can also come from businesses. We know that businesses have to use water, whether for drinking, whether for preparing meals in the cafeterias, and even the water that's used in the restrooms, washing hands and even going to the bathroom. Wastewater also comes from storm runoff. We've had some rain here the past couple of days. That rain is going to drag all of the oil and scum from the streets and the sidewalk, anything that's in your grass, and it's going to drag it to the sewer, and that's going to go down the sewer, and that has to be treated because water is recycled. We don't have any new water. Why should we treat wastewater? Because we want to care for our environment and overall our health. This is the reason why we should treat wastewater. So we're going to talk about specific reasons. One reason would be fisheries. Clean water is very critical for the plants and the aquatic organisms that live in the water. And essential, it also affects people who fish for food and animals that rely on the fish for food. Another reason why we should treat our wastewater is for wildlife habitats. Wildlife habitats live on land, but they rely on food in rivers, oceans, and lakes. And they get their food from the shorelines when it washes up on shore. Another reason is for recreation and the quality of life. How many of you would like to go to the beach if it was full of scum and glass and junk and dirt? No. And people move to areas because of beachfront. That's a quality of life. It's very tranquilizing, relaxing, and it's fun to be at. We also treat wastewater because of health concerns. If we did not treat wastewater, then it would put our lives at jeopardy for the bacteria left in the water, which would cause diseases that could potentially harm us short-term or long-term and even kill us. For example, cholera. Cholera is feces and comes from the feces in water. You can't see it. It's not like you get a cup of water and got poop flowing in it. Essentially you will, but you can't see it. The goal of sewage wastewater treatment, which means the goal of treating wastewater, is what? What do you think the goal is? To get as much of the solid particles out of it. To get as much of the solid particles out of the water before we put it back in the environment. Do not write that word for word. Get as much of the waste out of it before we do what? Put it into the environment or reuse it. And the way that we do that with something called a sewage treatment plant. And if you look up here, after you're finished writing, this is a bird's eye view of a sewage treatment plant. Notice it has many different components to the sewage treatment plant. And we're going to go through the components in a very condensed way on how this works for you. Now, first is the primary treatment. And your primary treatment is only going to remove about 60% of the solid suspense or the suspended solids. And these are the things floating in your water that you can see or you cannot see. And the very first step of the primary treatment is called raw sewage, which is screening. Now, your raw sewage or your screening is going to treat the wastewater by allowing the water to pass through a screen. It's going to catch your large objects, things like paper, bottle caps, even dead animals. All that's in the water. So it captures those things. Now, the screening is not big enough to capture everything. So it's going to capture what it can. From there, it will go to the settlement tank. And in the settlement tanks, your particles, like sludge, can sink to the bottom. And when they do, they're then filtered out like coffee grounds, filtered out in a coffee pot, letting what can pass through, and what can't. So it's a smaller filter. Notice your raw sewage is a bigger filter. Your settlement tank lets everything fall to the bottom, and it pulls out those things that can fit through. We still have other stuff there. Those things would be things like food, coffee, grounds, like from the dirt, soil, oil, and even other scum pieces that didn't get caught from the raw sewage screening. Then it moves to the secondary treatment. So that was just the primary first treatment. This is going to remove about 90% of the things that you can see and the things that you cannot see in the water. So that lets us know that there are still stuff in the water because nothing has gotten it out 100%. Your secondary treatment involves aeration tanks. And this is going to mix the oxygen with the bacteria. Why? We studied bacteria here. We know bacteria needs oxygen to survive. So we need that oxygen to thrive in that bacteria to thrive in our water. Why? Because that bacteria is going to feed on any of the waste. It's going to eat all that. And you're like, why do we want the bacteria to grow and grow in our water? How are we going to get rid of that? Well, we got a step for that. But right now in this, that bacteria is going to be very helpful for us because it's going to feed on the waste that's in the water because that waste could not be filtered out from the settlement tanks or the raw sewage. From there, we have another settlement tank. Again, stuff is going to settle to the bottom, which is why it's called the settlement tank. The water is filtered again using the same process, removing any other leftover small particles that were not caught before. From there, we then go to something called the chlorinator. Chlorine is going to then kill the bacteria that we let thrive to eat that waste. And then when chlorine kills that bacteria, then we release the water back into the environment. So our water into the environment includes what in it? Chlorine. Any questions? Okay, then that concludes this lesson.